Hi, everyone. Welcome to our technical demo session. So once again, my name is Christiaan Adams, and I'm a developer relations engineer on the Google Earth Outreach and Crisis Response teams. I have with me today my colleague, Christophe. Christophe, welcome. Do you want to introduce yourself?
Hi there. My name is Christophe Restif. I'm a software engineer on the Google Crisis Response team. I work on wildfire identification and delineation, and I focus on the data ingestion and the satellite image processing using Earth Engine.
Great. Thank you, Christophe. So we have some exciting stuff to talk about today. Christophe is going to show us some very cool data sets and techniques in Earth Engine. We'll focus on wildfire-related examples, looking at some of the near real-time data and ways to visualize it over time with animations. But these data sets and many of the techniques can be used for many other applications as well. I'll also note that this is not a detailed step-by-step tutorial for beginners. If you're just getting started with Earth Engine, I encourage you to also take a look at the Earth Engine sessions and workshops to help you get started. That said, this will hopefully still be interesting and inspiring for anybody at any level of Earth Engine use. No matter what field you're working in, hopefully you'll be able to use some of these techniques. So Christophe, can you tell us a bit more about what to expect?
So today we're going to show how to generate animations of wildfire evolutions using polar orbiting and geostationary satellites.
All right. Great. Before we dive in, let's talk briefly about how we use wildfire data today here at Google on Maps and Search. Just to set the stage, in times of crisis, many people turn to the tools they know, such as Google Search and Maps, and they're looking for information like what's happening, how bad is it, where is it, what should I be doing? To make it easier and more efficient for people to find high quality information, we built Google Crisis Alerts, which provide timely and relevant information for those people impacted by a crisis. This includes updates and instructions from local authorities, news articles, relevant social media feeds, and other helpful info. When the crisis is a wildfire, we also display a wildfire boundary map to show users an approximate area where the fire is active. To create those boundary maps, we use publicly available satellite data from the National Oceanographic and Atmospheric Administration, or NOAA, specifically their geostationary GO satellites, which capture imagery and heat signatures about every 10 minutes. That data is available directly in Earth Engine, our platform for remote sensing and geospatial analysis. We use it to compute the fire boundaries. So with Earth Engine's data visualization capabilities, we're able to show the rough size of the wildfire in near real time right on Google Maps for everyone, and refresh that data every hour or more. If you want more details on that process, go find the talk that Christophe gave about it at last year's Geo for Good Summit. But now let's check out some new techniques and some additional data sets to take this even farther. So Christophe, let's tell me what data sets are we going to be talking about today.
So today we will start with polar orbiting or low Earth orbiting satellites, sets called FIRMS. They have sensors that are dedicated to wildfire detection. In particular, they can measure the temperature of pixels. And as they orbit the Earth, they collect the data, and the data is usually in the forms of one image per day of all the Earth's surface. Then we'll also look at geostationary satellites, those 16 and 17 that are looking at Americas. They also have sensors dedicated to wildfires, and their refresh rate is much higher. It's about every 10 minutes. And we'll also mention external data sets like official outlines generated by fire agencies. The resolution is very fine for space. It's very detailed outline. And usually it's generated once a day or less than that. It's also available after the fire is done. So this is the three family of data sets we'll look at today.
Very good. All right, let's dive in.
So we're going to look at the fire called Dixie, which happened in California in summer 2021, especially August, was a very fast spread of this fire. We'll just create a little dictionary in Earth Engine to define the dates and the region that we're looking at. That way, if you are interested in a different fire, a different part of the world, a different time range, this is all the parameters you need to change. Also, just for people watching us, all the code that we are going to show is available in additional resources. I've made little sections. This is part 1 that we are looking at. That way you can follow along, or you can just look after the show. I'm just going to look at the snippets that are interesting for each section of this talk. Right now, we are looking at the firms dataset, which is available in Earth Engine catalog. Here's a link to this set with all the details. The band that we're looking at is called T21. It shows the temperature from 300 Kelvin to 500 Kelvin of the pixels as they are being imaged. So to visualize them, we're going to create a little visualization dictionary between 300 and 500, going from white to red. And then all we have to do is pick one image in this collection and show it on the map. So this is what it looks like. I've also added this rectangle in blue to say this is a region we are going to look at today. Let me zoom in a little bit.
Wow, there's a lot of activity in that day. Amazing. We can definitely see a lot from the satellite imagery there. Before we move on to animations, can we get a more realistic background than the blue rectangle there?
So yeah, that's a good point. Sentinel-2 is another satellite that is available in the Earth Engine catalog. So let's move to part 2 of our tutorial. From the link and from the catalog, there is actually a little snippet of code, a little tutorial, to explain how to generate a synthetic cloudless image at a pretty high resolution of Earth. And all we have to specify is a time range to generate this synthetic image and the region of interest. In this case, we'll just focus on our fire, Dixie. So I just copied and pasted the code there. I'm not going to go over the details. But basically, now we have one background image and one satellite image. In Earth Engine, you're probably familiar with adding multiple layers to your image to show it. But for our animations, we're going to want to actually combine these images into a single one. This is called blend in Earth Engine. So you're going to see a lot of this blend operation. I'm just going to highlight that I've called this Sentinel-2 image background image, my synthetic cloudless image. We're going to see this name coming up in a lot of the tutorials. I'm picking up August 5 as one of the images I want to show. And now I'm just blending them into a combined image and simply rendering it on screen. Hopefully, it should look just like the previous one.
All right, great. Yeah, that looks a lot better now. Cool. So I can even see the smoke in the background there on that Sentinel image from the fire. Very good. All right. Cool. How do we start animating this?
So first, we need to generate an image collection in Earth Engine that will contain all the frames that we want to display. So let's move to part 3 of our tutorials. We've already seen how to generate one individual frame. We call the visualize on the background image, and we call the blend function. All we have to do is do this for all the images of this frame collection. In Earth Engine, there's a method to do just that. It's called mapping.
That's mapping a function, not mapping data on a map, right?
Absolutely, yeah, we have to be. Yep. So when I refer to mapping, I'm really saying, let's apply one function over a series of images. So what is this function doing? Exactly what we've just done in the previous part. It's extracting the firm image, applying the visualization that we picked from 300 to 500 from white to red, and it's blending it with the background image. One more thing that we're going to do here, in firms, all the images have a timestamp to say when was it generated. We actually want to carry over these timestamps so that when we generate our animations, we can also select time ranges. In Earth Engine, this is very simple. We're just going to call the copy properties of the time start and time end of these images. That way, we end up with an image collection where each image is aware of its own time. Now, before we go into animation, let's just pick one image into this new collection to make sure we did it right. Once again, it looks just like the other ones. So now we can move to animations. Let's move to part 4. Once we have generated it, there are several ways in Earth Engine to generate a video. For this demo, we're just going to keep it simple, generate a simple GIF file in the console side of this tool using print and UI.thumbnail. We just specify the image collection, the projection, and then the size of this GIF file and which part of the world we want to. I wrap this little tool into a little function to make it a little easier for us because we're going to generate a lot of these little videos files. And I'm just going to present on the side 3 animations from July, 1 from August, and 1 from September. This is what it looks like. So on the top, you can see July. I'm going to scroll. Now you can see August. And I'm scrolling down, you can see September.
Awesome. I love the animations. Look at that. You can see the fire moving. Incredible. And you split these up into 3 different GIFs, I assume because of the limitations on GIF output size in Earth Engine.
Yeah, absolutely. With this UI thumbnail, there's a limit in how many pixels we can process for the trade-off that it's pretty fast to render. This is why I picked these 500 dimensions and 1 month at a time. If you're interested in higher spatial resolution or longer time periods, there are ways to export the files, the video, as a file in Drive or on your computer with export video. We're not going to cover this right now, but you can look at the documentation. It's a very similar idea. Once you specify your image collection, the rest is very simple.
Very good. Cool. So I see one of those fires is definitely moving, or the fire on certain days there is moving really, really fast. But it's a little jumpy. It's like it looks a little disconnected when it's 1 day at a time. Is there a way we can sort of make that more gradual?
Sure. So one way to do it is in each frame of this animation, we could show multiple days of data. So to combine multiple frames into one, it's pretty straightforward in Earth Engine. Let's move to this part 5 of our tutorial. And in this mapping function where we iterate over our image collection, we want basically to look at an image and look at the previous image in the collection. Now, in Earth Engine, an image collection is not aware of an order. You cannot say, give me the previous image in the collection. With an image collection, you can filter by date, amongst other things. So we could simply say, for an image, when I want to render it, filter from the day before or 2 days before, give me all these images. For the sake of this demo, I'm going to show you a different trick where I actually want just the previous index. I'm going to convert my image collection into a list in Earth Engine. It's called the function toList. Just a simple different data structure. But now the list data structure is aware of indexes, and we can refer to previous index.
Mm-hmm.
So it's going to make a little longer function in our mapping operation. First, we're going to look up the index of our current image in our list with index of. Then we're going to look up the previous index with get index subtract 1. For the very first image, we have nothing to subtract, so we're just subtracting image 0. We're just going to render this image like the one we did before. And now, when we are blending our images, we have one more image. We have the background image, we have the image from yesterday, and the image today. We blend all of them together, and that's it. Let's look at what the animations look like now.
All right, very nice. I can see the progression there. It's a lot smoother. Though some of the days look the same there. Can we use opacity to make the previous day disappear a little and have it be more of a real animation motion?
So yeah, absolutely. In this case, if you look at this visualize code, I use the same parameters for the previous day and the current day.
Okay.
So now let's tweak these parameters a little bit. So let's look at part 6 of our tutorial. I'm just going to use a new parameter in this visualization dictionary called opacity. We haven't used it yet. Very simple. It's a number between 0 and 1. 1, say, show me all the image. 0, don't show me anything. And I'm just going to wrap it as a little helper function. And now all I'm changing is the visualize line. Now for the current day, I'm going to say visualize with full opacity. And for the previous day, I'm going to say visualize with 50% opacity. While I'm there, I also copy-paste to show the image 2 days ago and use an opacity of 0.3. And you can show as many days as you want this way. And now this is what it looks like.
Very nice. I love it. You can really see it moving there. Get a better sense of how fast the fire is moving, really. So with transparency, we get an idea of how the fire changes from one day to the next. Can we show those differences between days in a more quantified way?
Sure. So with Earth Engine, it's very simple to do mathematical operations on images. Right now, we've just combined them visually, but we can do math on them. We can subtract them, subtract all their values, pixel per pixel. So this is going to be part 7 of our tutorial. We start with images whose value is between 300 and 500. So when we're going to subtract them, we end up with values between minus 200 and 200. So the first thing to do is change our visualization dictionary to readjust our scale. Also, to make it a little more visually appealing, I added colors to our color range. So now I'm going to use blue, cyan, and green for negative values, and the yellow, orange, red for the positive values. Now, this mapping function that generates our image collection that we animate is going to be a little simpler now. Just like before, we pick up the previous image using our index. But now, instead of saying blend these images with transparency, we say subtract them. And we end up with one image that we add to our collection. And this is what it looks like. So in these videos, red and orange mean this pixels is hotter than before, up to 200K hotter than before. And blue and green mean this pixels is cooler than yesterday, 200 to 100 degrees cooler than yesterday. And this is what it looks like month per month.
Very nice. I love it. That gives a really different outlook on what it means to visualize a fire evolution in a different way. I'm sure you could think of other and more complex ways to combine the data beyond the simple difference. But how about we switch gears right now and talk about fire outlines?
Sure. So with the firm's data, it's actually pretty straightforward to generate outlines. Let's move to the next part of this tutorial. Conceptually, we'll have 3 steps. First, we are going to combine all these firm's images into one. Combine all the values, take the maximum values. This is a part where we say maximum. Second, we're going to simplify this image to make it into binary values. 0s if you are outside the fire, 1 if you are inside the fire, with this simple operation, still, temp, and int. Now that we have this sort of binary mask of you are inside the fire, you are outside the fire, the last step is to use the Earth Engine method called reduce to vector, which does just this. Taking this binary image, it'll generate an outline out of it as a feature collection. We need to specify the spatial resolution. So here I'm saying, let's generate it at 100 meters resolution. Now that we have a feature collection, in Earth Engine, it's like a geometry, and we want to render it. One way to get a lot of flexibility to render a feature collection is to turn it back into an image. So this is what this function does. We're going to paint this collection into an image with a specified width and color. So we've generated this outline, and now we've generated one image that contains it. And let's look at it on the map. This is our complete fire outline.
Wow, yeah, you can really see how big that fire got, unfortunately. It was one for the records. All right, Christophe, so can we add this to the video animations that we made before?
Yep, it's very simple at this point because we have this simple image, just like we had the background image before. So let's look at the next part of the tutorial. Basically, we're just going to add it to our blend operation in the mapping operation. Just instead of showing it on a map, we're adding it to our blend, and that's all it takes. Let's look at the results. So we have
Yeah.
July, August.
Wow, look at that. Each of the months there. You can really see the fire progressing and how it built up that outline. So cool. So we generated the complete outline using the complete time range there. Can we do it step by step and see how the outline grows over time?
Yep, let's do this. So let's move to section 10 of our tutorial.
Mm-hmm.
As we were generating our outline, let's build a little function where we can specify the start and end date. Everything remains the same. We'll use the same trick to generate it as an outline. And now I'm just going to show you 3 outlines between the start and 1st of August, the start and 1st of November, and the start and 1st of October. Let me disable these layers. So this is what it was after 1 month. This is after 2 months, and this is after 3 months.
All right, so you can see the progression there. So can we incorporate it back into the animations?
Yep, that's a good idea. So in the previous animation we were just adding the static image. Mm-hmm. Now we can just add these images. Again, it's just part of the blend operation. So this is section 11 of the tutorial. We're just going to blend a different image. Now, I have to give a little caveat at this point. This is really for demo purposes to show the concept. The computations are getting a little inefficient at this point. At this mapping operation, for every image we process, we're going to reprocess the image collection to generate the outline at the same time. That makes a lot of computation on the same image collection. Us Engine is going to complain. So I'm going to reduce the time range of the videos to 2 weeks at a time. Now, if you want it to be more efficient, one way is to generate this list of growing outlines, save it as an asset. That way, when it's time to use it, we just have to load one image instead of recomputing everything. So this is what it looks like 2 weeks at a time.
Very nice. Those are great videos. Look at that. You can see the fire hotspots moving and the boundary growing in the corresponding way. Awesome. Great way to really visualize the fire evolution. So can we do this with any other satellite imagery?
Absolutely. A lot of this code can be directly reusable for other datasets. So we talked about GOES before, so let's talk a little more about them. That will be section 13 of this tutorial. Last year, we presented a talk and we made a blog post that gives all the details of this processing. So I'm just going to give you a little overview here. We have geostationary satellites. They are further away from Earth, so the pixels are bigger. But because they stay looking at the same place, they give us an image every 5, 10, 15 minutes. Now, instead of giving us a temperature between 300 and 500, they give us a mask value that says, how confident are we that there is a fire here? Now, to reuse our steps that we have, all we have to do is convert these mask values into numbers, for example, between 0 and 1. and then change our visualization dictionary to say 0 is white, 1 is red, and orange and yellow in between.
Mm-hmm.
So I went ahead and copied all the code from last year's tutorial in here. As you can see, I'm changing the visualization here, and then I'm just blending to the background image again. Very similar steps. And oops, where is my image? Oh, sorry, it's an animation. It's on the other side. These are the two animations. Because we have one image every 5 minutes, it's a lot more data. So again, as we talked about these limitations for this chip, I limited to 1 day worth of data for each of the satellites. We are looking again at August the 5th, that day that was particularly active. The top animation is GO 16, seeing from the east side. The bottom is GO 17, seeing from the west side.
Interesting. So that's just that 1 day that had a lot of fire activity, as I guess we can see there. Amazing. So let's see, we did firms, we did GOs. Can we combine them? Is that possible?
It would be very cool to combine them and to have an animation with both of them at the same time. It's a little tricky because firms and the polar orbiting combine all the data into a single day. So what we could do is combine all of GOs into a single day, and then it'll be easier to compare them day to day.
Makes sense.
So to combine GOs into a single day, we're just going to look at the maximum fire activities that was picked. You can think of other way to summarize 1 day. It doesn't have to be the maximum. It could be any other summary, median, variations, whatever you like. For the sake of this demo, we'll just summarize by the max operation. So that's going to be our next section. We're just going to use the reduce operator to say reduce to the max. Also, I'm going to combine the two satellites into a single image, GO 16 and GO 17, with the minimum. Again, all the details are in the blog post. But that way, we have 1 day of firms and 1 day of geostationary satellites. Let's see what they look like. And I'm just going to hide some layers. So this is our background image. This is the polar orbiting. And this is the combined GOs on the same day. I'm just going to keep highlighting them.
Interesting. So, yeah, very cool. You can really see the difference that the temporal, or sorry, the resolution makes there. It looks like one region wasn't picked up since the fire moved maybe so fast that day.
Yeah, the fire progressed so far in this period, in this region where I'm scrolling the mouse around. The polar orbiting didn't pick a lot of temperature, it's pretty low. Most likely the fire moved while the satellites were looking somewhere else. Now, the good thing with geostationary is actually picked all this fire progression.
Right, so the GOES data shows the entire day there, everything that burned, while the geostationary just picked up part of the day.
Yep.
Okay. Very nice. So let's see, besides the satellite imagery, are there other sources we can use, other data sources we should try out here?
So yes, in the US, there is a national agency called the National Interagency Fire Center, or NIFC. It provides official outlines for fires after the fact and sometimes also as the fires progress. It's public data available in multiple formats like GeoJSON, shapefiles, and others. Usually, it's really very accurate at the spatial resolution, so you get a very, very detailed outline. And for some fires, you can even see several days as the fire progress, how the outlines progress. Now, this is publicly available data that you can download in any format that you like and re-import it in Earth Engine as an asset in your collection. It will appear as a feature collection. So that's what I did in this section here. I went ahead, downloaded it from this website, and imported it. Now I'm just going to display it on the map. So you can see all the field polygons. Blue polygons are the official fire outlines. And in red, this is what the polar orbiting satellite picked up for this Dixie fire.
So the red one is the one that you just generated on top of the official one.
Absolutely.
Very interesting. So you can see they're pretty close. The general shape is almost the same, but our generated boundary is a little bigger. I guess one of the reasons is the pixel size of the satellites we're using as compared to the more detailed analysis for the official boundaries.
Yep, absolutely.
Very interesting. Any other tricks you can do with that, Christophe?
So I just want to show you a very different way to process the images, to have a visual effect that's different. We can smooth the pixel edges in our animations. So that's going to be the last part of this tutorial. We've seen how to combine images. Now I'm just going to say how to smooth one single image. It's called reduce neighborhood. This is the operation. We specify the filtering, it's called a kernel, that we want to blur the images with.
Okay.
This has the two effects. It will make the edges of pixels a little smoother. Also, instead of having sort of stepwise variation from one pixel to the other, the values are going to be a little more continuous. And visually, it makes for a smoother experience. This time, I'm going to change the image collection first, process all this image with this smooth operator, and then regenerate our final image collection with our mapping operation with the same pixels as before. And let's look at the 3 months as we've done before, July, August, and September. You can see just a smoother visual.
Very nice, super smooth. It's a real animation there. Awesome. That looks great, Christophe. Thank you. Wow, we covered a lot today, short amount of time. Made some videos where we merged multiple days, either with transparency or mathematical operations. We generated outlines, very cool outlines, both complete outlines as well as the gradual over time outlines. We looked at firms data, GOES data, the official NIFC fire boundary data. So I hope everybody found something interesting or inspiring in this demo. Something you can use hopefully in your own data visualization and come up with your own ideas for how you can use these techniques to explore wildfire data or other data sets. So again, to see all the code that Christophe showed us today, you can go to the resources link below the video in the Summit website, and each part of the demo should have a link to the code there. Thank you so much, everyone, for watching. We look forward to answering your questions in the Q&A session in just a moment, and do stick around after that for some exciting talks from several of our partners coming up in just a few minutes. Thank you.
Thank you.
Hi, everyone. Welcome to our live question and answer session. I hope you enjoyed that demo and found it interesting and inspiring. Once again, my name is Christiaan, and I'm a developer relations engineer with the Earth Outreach and Crisis Response teams. And with me here is Christophe, a software engineer on the Crisis Response team and the brains behind most of the fire mapping work we have here. So welcome, Christophe.
Hi, everyone.
So you just watched us deep dive into the fire-related data sets available in Google Earth Engine and how you can generate hotspot maps and fire boundaries over time and then create animations of those visualizations. All great stuff. you've been asking some very good questions, and we're excited to answer them. So a reminder for everyone watching, it's not too late. You can still submit your questions right down below the video in the Q&A section down there. So let's get started with our first question. Ready, Christophe?
Yep, it is.
Cool. All right, so from Raj. Raj, thanks for the question. He asks, besides the fire, can you do the same with the smoke we see in the satellite images?
I wish we could do in a similar way. It's definitely possible because there's a few satellites who pick up these images. There might be some issue at night. That's the only difference compared to the thermal imaging we get from infrared. There's a few links we can post in the resources. I think there was a blog post, Christiaan, I believe, Medium blog post that explains how to do this.
If you look at the Google Earth Medium blog, there was a post some time ago about animating smoke and fire with GOES data. So that's available. I believe we also did a Google Earth outreach on-air session. I think it was over the summer. That was a technical demo of how to animate the imagery of smoke and clouds and things like that for fires and hurricanes and things. So we'll find a way to get you guys all the links to those. And yeah, you can. Those are definitely things you can do. So let's see. The next question is from Emil. Thank you, Emil, for this question. Is there any chance that you will add the FIRMS VIRS products in addition to the existing FIRMS MODIS data?
Yeah, that'd be cool. Definitely. It's on Earth Engine's radar. They have a list of satellites they want to ingest and make available in their catalog. So they have a tracking request for this. We've passed the questions to them, and they're adding it as a vote to say, we want it. So again, we can post a link in the resources. So that way you can track the progress on this, and hopefully it will be here soon.
Great. Yeah, we'll put a link to our Earth Engine dataset issue tracker where you can submit data requests. I know that one's already in there. And like Christophe said, we'll consider this another vote for that dataset. So thank you for that. Another question from Emil. How about adding times and dates on the animated GIFs? I guess like text labels on the GIFs. What do you think about that?
Yeah, it's always a super important visually to be able to see the timestamp as it goes by, especially for fires. We all know how important it is. It doesn't come easily in the sort of a simple version, the code editor. So what some developers, in particular one person called Jenna, has developed a little module that's publicly available, which makes it very straightforward to add text to an image and a few other effects. So again, we'll post a link to that repository in the resources. Basically, you just include it in your script, and then you have access to all this library of functions.
Very cool.
I've used it personally, so I think it's very, very effective to do exactly this, adding the text where you want it to be. I didn't add it to this demo because we just wanted to keep it all about the images and not about the text itself. And if you want it as well, once you've exported the file as a video, for example, MP4 or something else, you could also use another software to add text to it or something else. It's sort of like going beyond Earth Engine, depending on the volume you have, the sort of images annotation you want to do, and what sort of software you have available. So yeah, we'll just put these links again in the resource section.
Yeah, and hopefully our colleagues watching the Q&A section can paste some of these links in as answers to these questions. If not, we'll make sure that we get links to these things out to everybody. Cool, thank you. Let's see, our next question is from Scott. Thank you, Scott. Can you export the visualizations? And if so, what file format should you use?
Yeah, definitely. If you use the code editor, in the left side, you'll have a little doc tab where you can see the documentation for existing APIs. If you look for export and video, you should see the command line. So I used the GIF, the print section and the GIF. you would just replace this call. It takes very similar arguments. You can definitely export MP4. From the top of my head, I can't remember all the other formats. There's a few others. And again, it's like in the public API description, like either from the code editor, or you just go online and you have the reference to the different formats. You can also export it to Google Drive or as a file to download directly. The good thing is when you use this, you can fit more pixels, and either you want like bigger duration, more resolution, bigger region, and so on and so on. So I've done it for myself several times to just have a finer resolution, so more pixels per meter. And it's just one line of code to change. So I definitely encourage you to look into it. The little GIF preview, I use it just to convince myself that, okay, it's the right time range, the color range, time scale is okay. I usually do even a smaller resolution than what I've shown in this demo, just to make it super fast and say, okay, the color is really off or something I missed. And then I just, I saved as a video. You could also, from these little previews, you could do a right click and save as a GIF, but I prefer to use the big video files.
Yeah, I was going to say that you can just right click on those GIFs like any other image and save them to your hard drive. But if you want a higher resolution or a longer video, then saving it to an MP4 is probably the best way to go. Cool. Next question is from Jilang. Thank you for this. The pixels in Firm's image look slanted. Was that because it's displayed in a different projection? And is there a way to make the pixels appear rectangular in shape?
Yeah, good catch. So yeah, it's a matter of projection, and by default in Code Editor, adding these images doesn't come with an explicit reprojection. So if you specify the proper reprojection, and I'm just looking at my notes to find the right thing, EPSG 3857, like the pretty, it sounds obscure, but it's fairly standard projection. And by specifying the projection to use, you would have a rectangular.
Great, yeah, so you should be able to adjust that. Cool. Thank you to Gemma for the next question. They ask, is the red line mapping total extent of burned area from the fire?
Yes, so this is what we were going for. We wanted to see from the beginning to the end. It's really up to you. When you specify the start end and the start date and the end date, what do you want to see? Do you want to see the evolution from the beginning and trying to find an actual beginning date early on? You can really play with this parameter to see the extension one day. And just a little caveat, I'm always a little sensitive of the words. We want to say it's a burn area, but really what the satellites pick is the heat emitted from there, especially at the edges. The pixels are like still a few kilometers big. We don't know where in the pixel the heat is coming from. So it's important to keep in mind that this is good to give us an idea of the size, the overall size and the overall geometry and where it's evolving. However, if we zoom in on the detail at the border, it's not that accurate. We won't be able to find like 500 meters accuracy from geostationary satellites. So even though it is meant to represent the total burnt area, at the edges, it comes with some inaccuracies. Also, just by the nature of fire and wildfire, not everything inside is burned. Fire can skip regions. We've seen in places where like a whole block can be completely unburned while everything around was completely burned. So even though these satellites definitely tell us there's a lot of heat here, we don't know exactly where it happened. So personally, I like to think of it as affected area. This is like very, very close to really hot heat coming from the fire. Not necessarily the burn scar or the burn damages or something else. This is very hard to see from geostationary or even polar orbiting satellites.
Yeah.
Visual data or being on the ground will never replace.
Yep. Sounds good. Yeah, good reminder that this comes from pretty big pixels, so it's rough around the edges, so to speak. Let's see if we can squeeze in another question or two here. Akira asks, can you map with evacuation areas, safe areas of escape, to check the safety in their community? Do you know any resource with an evacuation map? I can answer that I don't. Right now, we don't have evacuation data on the maps, and that's data that comes from the government agencies in each place. So that's a little difficult right now. I don't know a good source for that. And then finally, let's see. Actually, I think we're almost out of time here, so I'm going to cut it off here, and hopefully we can answer the rest of the questions in the Q&A section under the video. But we're about out of time, so I'm going to end it. And thank you, Christophe, for all the great work. Thank you to all the participants for joining us and for all the great questions. Very excited to have those. Next, we have a break coming up for a few minutes. So take a break, and then please stay tuned, because coming up right after the break at 45 minutes past the hour, we have a great lineup of lightning talks coming up from 4 partners and experts talking about how they use Google Earth and Earth Engine for their work in everything from wildfires to flooding. After the lightning talks, we will be hosting a meet and greet session. So come and join the Google Meet and mingle with us and members of the community. We're looking forward to meeting all of you. So hope to see you there. And thanks again, everyone. Have a great summit. Bye-bye.
Thank you.